In this video, I'll be discussing inverse matrices and determinants. In a matrix, the determinant of a matrix A is denoted by DET for determinant, and it looks like absolute value signs around the matrix A. Note, please, you can only take the determinant of a square matrix, a 2x2, 3x3, 5x5, 7x7. The formula for the determinant of a 2x2 matrix is denoted by A of 1 times B of 2 subtracted by A of 2 times B of 1. So you're basically going to be multiplying diagonals and subtracting them from each other. So for example, if I was to find the determinant of matrix A, I'm going to multiply the diagonals together. So 5 times 1 is 5. And I'm going to subtract that from the other diagonal, which is negative 8 times 4, which is negative 32. And 5 minus a negative 32 is 37. Now to find the determinant of a matrix that is a 3x3 or more is a little more complicated. I'm going to show you using a calculator first. At the end of the video, if you would like to continue to listen, I am going to show you how to do it by hand. So what you're going to do is you're going to pull up your TI-83 or 84 calculator. You're going to go into the matrix and you're going to edit a matrix. So I'm just going to edit matrix A. It is a 3x3 and I'm going to input the numbers. When you're done, hit quit. Now, you're wanting to find the determinant of matrix A. So if you go over to math, you're wanting the DET for the matrix. So hit enter, and now you need to let it know which matrix you want. So go back into matrix and choose the matrix that you had just edited. It is matrix A, so if you hit enter, it will give you the determinant, which is negative 272. Now, the reason we discuss determinants is because they are actually used when finding the inverse of a matrix. In algebra, the multiplicative inverse of 8 is 1 over 8 because if you multiply them together, you will get the identity number, which is 1. Same thing happens in a matrix. The inverse of matrix A is denoted by A raised to the negative 1. And if you were to multiply any matrix by its inverse, then the product actually becomes the identity product, which is a diagonal row of 1s and all other numbers being 0. Again, please note that you can only take the inverse of a square matrix. So to find the inverse of this, at the end of the video, I am going to come back and show you how to find the inverse by hand, but for the time being, I'm going to show you using a calculator. So what you're going to do is go into matrix. We are going to edit a matrix. I'm going to use A again, so I would say 2x2. It is 1. Once you've inputted the numbers, you're going to quit. Now, normally when we go into matrix again, we go over to math because we're going to manipulate it. You actually do not have to do that for the inverse. You're going to choose the matrix that you just edited, which in this case is matrix A, and you're wanting to raise it to the negative 1, just like we discussed of the notation. You're going to hit enter, and it actually is going to give you the matrix. So the matrix for this, the inverse for this matrix is negative 3, negative 4, 1, and 1. Now, to find the inverse of this matrix, we can do the exact same thing. We're going to go into the matrix. We're going to hit clear. We are going to edit a matrix. It is a 2x2. And then quit. Go back into matrix and select the matrix that we used, that we edited. We're going to raise it to negative 1. However, we get an error here. And here is why an error actually happens. In order to find the inverse of a matrix, part of the formula is you're going to divide 1 by the determinant of that matrix. However, here's what happens. If you were to take the determinant of this matrix, you're going to multiply the diagonals together. 3 times 2 is 6, and negative 6 times negative 1 is a positive 6. 6 minus 6 is 0. Therefore, as part of the inverse, you're going to do 1 divided by the determinant. But because the determinant is 0, you actually cannot have an inverse because you cannot divide by 0. So there actually is no inverse in this case. So it is possible for you to come across a matrix that does not have an inverse. Okay, I want to go back and show you how to do a matrix C by hand. So here's what you do. You're going to take the first row in the first column. The 5 is what is being overlapped or intersected. So you're going to multiply 5 times the determinant of the 4 numbers not used. So 4 times 3 is 12, subtracted by 0 times 7, which is 0. Now the next thing you're going to do is subtract the next expression. In which case you take the first row and you take the middle column. The 6 is what was intersected, and now you take the determinant of the 4 numbers in this case. Negative 2 times negative 3 is negative 6. 8 times 0 is 0. And on the third case, it's going to be a plus sign again. So the middle one is a negative, and then the next one is going to be a positive. And you are going to go the first row in the last column. 8 is what is being intersected, and you're going to take the determinant of the 4 numbers not used. Negative 2 times 7 is negative 14. 8 times 4 is 32. So you will get 5 times 12, which is 60. Negative 6 times negative 6, and then a positive 8 times a negative 46. If you were to put these numbers into the calculator, you'll get 60. You will get negative 272, which is exactly what we got. In order to find the inverse by hand, you're going to follow the formula that states 1 divided by the determinant of the matrix. And if the matrix is A, B, C, D, then the inverse of that is going to be 1 divided by the determinant of the matrix. And then your new matrix is going to be DA. They're going to swap sides. And it's going to be negative B, negative C. So therefore, in this case, you're first going to find the determinant. So the determinant is going to be 1 times negative 3, which is negative 3, minus negative 1 times 4, which is negative 4, which becomes 1 over 1. So the 1 divided by the determinant is actually just 1. And now you need to switch the sides. So if this is A and this is B, this is C, this is D, then your new matrix is going to be negative 3, 1, and B is going to go from 4 to negative 4, and C is going to go from negative 1 to a positive 1. So B and C stay in the same places, but they change signs. A and D actually switch places, and then it would be 1 divided by the determinant in the front, but the determinant was 1, so you are done. Now, this only works for a 2 by 2 matrix. A 3 by 3 is more complicated that we'll never get into, which is why we use the calculator, but that is a 2 by 2 by hand.